Welcome to NASA Science Live. This is your chance to interact with NASA experts and have your questions answered in real time. I'm your host, Raquel Villanueva. Earth had the Wright brothers, Mars had Ingenuity. Today, we're going to talk about the Mars helicopter. It's been almost 3 years since Ingenuity made history, proving controlled, powered flight is possible on other worlds. Ingenuity was designed for up to 5 test flights over 30 days, but it went well beyond those expectations. The helicopter completed 72 flights. But on that last flight 2 weeks ago, the rotor blades were damaged and the mission came to a close. While it may be the end of the era, Ingenuity's legacy will last for many years to come. If you have any questions throughout the show, you can send them in using the hashtag AskNASA on social media or drop them into the comment box. We'll get to our team of experts in just a moment, but first, a little more backstory. You might remember Ingenuity hitched a ride with the Perseverance rover, and it's been pushing the boundaries of what is possible ever since it got dropped off on the Martian surface. The 4-pound helicopter was a technology demonstration, proof that it was possible to fly in the thin atmosphere of Mars. Ingenuity spent nearly 128 minutes flying, covering over 11 miles and reaching altitudes as high as 79 feet. Each flight brought new insights to the team as they continue to challenge it to do more. We caught up with Chief Engineer Travis Brown for a breakdown of some recent milestones.
The Ingenuity Mars Helicopter was designed to push the limits, and I'm going to show you how we've taken it to the extreme. Today, we're here in the Aerial Vehicles Lab at NASA's Jet Propulsion Laboratory, where we develop prototype helicopters. Ingenuity started off as a tech demo to push the aeronautical boundaries over the course of 5 flights. Then we transitioned into an operational demo phase where we partnered with the Perseverance rover to do science and scouting. But about a year ago, when the Perseverance rover started racing up the Jezero Crater Delta, we actually found that we had to work pretty hard to stay ahead of the rover. We decided it was time to shift gears again, once again pushing the boundaries of Martian flight. This campaign really began in earnest with Flight 49, where we simultaneously set new speed and altitude records. By Flight 62, we had nearly doubled our max speed and doubled our max altitude. We also tested different landing speeds, faster to save energy and slower to reduce landing loads. Both of these strategies may be used on future helicopters. We performed a type of flight testing called system identification. This is a crucial but risky procedure that helps us understand the vehicle's performance by how it responds. Our team also devised new ways to target the high-resolution camera, which allows us to provide advanced reconnaissance imaging for the rover. And we were able to take stunning shots like this one of Belva Crater from Flight 51. In addition, Ingenuity conducted several first-of-their-kind experiments on Martian wind and dust movement, which gave us new insight into the Martian atmosphere. What we've learned will help us design the next generation of Martian rotorcraft. We're testing more efficient blades. We're also working on a Mars science helicopter concept that could potentially transport heavier payloads and take us to more exciting locations on Mars. When people look back at Ingenuity, I really hope that they see how much this one small helicopter has done to elevate the limits of human achievement.
Thank you, Travis. Let's meet our other experts, but first, a reminder that you can have your questions answered live during today's show. Submit them using the hashtag AskNASA on social media or drop them into the comment box. Today, I am joined by Teddy Tzanetos, Ingenuity Helicopter Project Manager, and Tiffany Morgan, Mars Exploration Program Deputy Director. Thank you both so much for being here.
Thank you so much for having me today, Raquel.
Thank you, Raquel. Excited to be here.
Thank you, Teddy. So I have a question for you. I understand that even though flight operations are over, the helicopter remains upright and you are able to communicate with it. What has your team learned in the past few days?
An incredible amount. Yes, we do know that we've reached the end of our flight operations, but miraculously, this little aircraft is tougher still than we could have ever imagined. We do believe that with Flight 72, we had a blade strike with the surface of Mars, and we have images showing damage to our rotor blades. But our baby is still upright. She's power positive. We're getting energy on the solar panel. And in the last couple of days and in the days ahead of us here, the team will be executing some additional sequences to try and piece together the pieces and really understand what might the moments of that impact look like, and also what is the state of the rotor system. Obviously, from the images being shown, it's pretty clear cut that the carbon fiber thin blades have been damaged. But the team is going to do a series of investigations where we're going to try and wiggle the blades, spin them slowly while we record some video footage, and try and get as much as we can and learn even more than we already have with Ingenuity in the days and weeks ahead of us here.
Yeah, Teddy, to kind of follow up on that, like what will happen over the next few days and weeks with Ingenuity, and can you go into how it will involve Perseverance?
Absolutely. So currently Perseverance is to the southeast of Ingenuity, and it's on its journey west. And in the days and weeks, depending on the rover planners and science priorities, Perseverance will get within line of sight of Ingenuity, but several hundred meters away. While that's happening, the Ingenuity team, we've already uplinked our first activity where we will be wiggling the blades. When we say wiggle, the technical term, that means we're going to change the angle of attack of the blades, but without rotating them. And the team is going to record a video while we do that. That'll be our first step. Second step, once we've established that our servo system is still healthy, we will do a simple push of the blades where we will try and rotate them 180 degrees very slowly, and again, try and record a video of that. And that will show us the other side of the rotor system. We suspect, based off of the images we've seen so far, that all 4 rotor blades are damaged, but until we rotate and get imagery on the other side, we're not certain. And there's additional steps that the team's still considering right now and weighing the pros and cons of, once we do that, should we try and do a low-speed spin and try and characterize how well did the rotor motor hold up. But it is certain that once we're done with all of the investigation process, we've reached the end of our flight operations. She won't be able to fly again. Helicopters like this are not designed to fly even with the smallest fraction of a gram of imbalance. And we're going to have the end of our mission in the weeks ahead here.
Looking forward to the updates. And as Teddy pointed out, we still have so much to learn from Ingenuity, which brings us to the future. Tiffany, what has Ingenuity taught us about what is possible on other planets?
Well, as you've already heard, Ingenuity was a technology demonstration. Technology demonstration is an effort that allows us to take more risks so that we can understand the capability. It's not required for the primary mission. Perseverance can succeed without Ingenuity. But Ingenuity so far exceeded our expectations. It was so valuable not to just demonstrating the technology, but to feeding forward for future missions. It has provided us real data that we can use to improve upon current designs and future designs for exploring other planets. Not only did it help us with designing for future missions, but it also helped with Perseverance's current mission. It scouted ahead and took a sneak peek at the operations that Perseverance was going to experience, and it allowed the planners to, navigate the terrain as well as to identify potentially compelling science targets. It's the NASA JPL team didn't just demonstrate the technology, they demonstrated an approach to technology demonstration that if we use in the future will really help us to explore other planets and be as awe-inspiring, as amazing as Ingenuity has been.
Speaking of awe-inspiring, Tiffany, how would you describe the legacy of the Mars helicopter?
Well, it was the very first powered aircraft powered and controlled aircraft on another planet. It will always hold that title as the very first, and it achieved so many feats in the Mars thin atmosphere. But I really don't think that the legacy for Ingenuity has been defined yet. I think it's to be continued. If you take our first roving rover, Sojourner, and everything that came after Sojourner, we had Spirit, we had Opportunity, Curiosity, Perseverance, taught us so much and really changed the way that we explore Mars. I think that Ingenuity will continue to amaze us in what it can feed forward and what its legacy will be in the future. It's just been wonderful, and I think it's going to teach us for years to come.
Absolutely. And Teddy, we know the legacy of Ingenuity is important to you too. What would you like to say to your team who made this all possible?
Yeah. Now that we've had a couple of days to process, and everyone should keep in mind, right? When we signed up for the technology demonstration, it was a 30 sol mission. A sol is a day on Mars. So we are a small team for Ingenuity. It's members here at NASA JPL, Ames Research Center, Langley, AeroVironment, and a handful of other organizations that have poured their heart and soul into this little spacecraft and this little aircraft for about a decade now. And seeing it go through its marvelous journey from a successful tech demo to checking the box on flight 1, our job was done, and really pushing the envelope across all the different axes of exploration here in the last 2.5 years of extended mission operations. It's been the mission of a lifetime for all of us. And I wanted to say thank you to all of the people here that gave their weekends, their late nights, all the engineers, the aerodynamic scientists, the technicians who handcrafted this aircraft. It is a hand-built spacecraft, all right? Every single solder joint is a testament, really, to quality and the dedication of all the people that made Ingenuity possible. And I just want to say thank you to the team, and for everyone listening here. We couldn't be prouder or happier with how our little baby's done. So thank you all.
And thank you, Teddy and Tiffany. Remember, we have lots of questions coming in from viewers watching online. You can submit them using the hashtag AskNASA or by posting them in the comments wherever you're watching today. Our first question is from T on X, who asks, how was Ingenuity able to outlast everyone's expectations? Great build quality, luck, or all of the above? Teddy, I'll let you have a go at that one.
All the above. There's a first part of it, which is a robust design, right? The coaxial aircraft design has been proven now. We've now, it was a theory that it would last and it would do well at Mars, and now it's a fact. So the engineers did a fantastic job proving out that the design is robust. I mentioned a second ago the technicians. That is a huge part of it. I would say the technicians, when you think of how did we survive this long, if you take a spoon at home and bend a spoon back and forth 5, 10, 15 times, eventually the spoon will snap. All of the hundreds up to close to 1,000 hand solder joints on Ingenuity, every single night on Mars they do this, right? And they're cell phone parts we're talking about, right? So the fact that Ingenuity has lasted that long with cell phone commercial off-the-shelf parts is the technicians. And then let's not get too excited, right? There's also a good amount of luck, right? And we should be thankful for the fair amount of luck we've had in the mission, but I don't want to discredit the team. We have had a fantastic effort on the engineering side and on the technician side to try and make the absolute best spacecraft we could for this technology demonstration.
And Teddy, we have another question for you. Pavel on X asks, rotor damage looks fairly small. Can it not take off because of the thinness of the atmosphere with this damage, or is there no point in even trying?
Yeah, so two parts. There's two aspects to that. One is just rotational dynamics. The way a coaxial helicopter, and every helicopter, even helicopters here on Earth, the way that they work, is that you spin your rotor system very, very quickly. And as you do that, you push air down. Anyone who's ever spun a top, right, will know that if it's not well balanced, it wobbles, right? So these rotor blades are perfectly balanced to the fraction of a gram. And if you offset that balance, you're going to induce a lot of vibrations, which will cause a lot of bad things to happen. The second part of that is I actually have one of our new prototype blades here. What's important to note is that as the rotor blade rotates through the air, the outer part is the fastest moving part of it, and the inner part is slower. The fastest moving part is where you generate most of the lift. And if you look at the shadow, the image of the shadow, we think about the last the furthest out 25% of the rotor blade itself is missing. So we have lost, the most important from a lift control perspective, part of our rotor blade. Even if we were somehow perfectly balanced, our thrust capacity has been significantly degraded.
And Basil on X wants to know, our fourth grade class at PS 174 in Queens has questions. Hello. How did you get the idea to build Ingenuity, and how long did it take to build? Teddy, we'll start with you on that. And then Tiffany, if you also want to chime in as well.
Sure. So our chief engineer, Bob Balleron, back in the 90s, first started thinking about the physics and just on the back of a napkin, taking the aerodynamics models and the physics that we know here on Earth and trying to apply it to Mars. The big change, the whole reason why this is hard, is because Mars's atmosphere is very, very thin. It's about 1% the density of Earth's atmosphere. So Bob started looking at that back in the 90s and then put it on a shelf. And then around 2012, 2013, 2014, this new Mars 2020 mission was coming up, and there was a discussion of between Bob and Charles Alachi and a handful of other individuals. Hey, Bob's idea, could we pull that off now, right? And it was a confluence, it was a coming together of a lot of technologies. I mentioned earlier the cell phone industry. You could not build in the 90s because cell phones didn't exist, right? The chips inside, the miniaturization, lithium battery technology didn't exist. So it was really the perfect timing of a mission opportunity going to Mars with Perseverance and Mars 2020, a team of excited engineers here at JPL and our partners, and the advancements of and low-cost advancements of commercial parts like cell phone chips, cameras, accelerometers, gyroscopes, and lithium battery technology that coalesce together to really give you the opportunity to try and pull this off. Yeah.
Tiffany, do you have anything to add to that?
Sure. Well, I can say, NASA is an organization that fosters innovation and diversity and enables teams like JPL's Ingenuity team to come up with ideas like this. So I can't tell you what it was like, to think of this idea for the first time, but I can tell you all of the things, or many things, that we've been thinking of doing with the capability now that it's been proven. What are the places on Mars that we can't access right now with a rover? What would the helicopters enable us to do? Could we, at a low cost, deploy small sensors and collect more science data? So what they've done in terms of proving the technology has enabled us to think about how the capability can be used in the future.
And we have a few more questions coming in from this fourth grade class. Tiffany, will Ingenuity come back to Earth, and how do you feel when it surpassed your predictions about its flights?
Oh, wouldn't that be awesome if Ingenuity came back to Earth? NASA plans to send humans to Mars, so maybe our astronauts will bring Ingenuity back someday. It is a lot of payload to bring back, but it could potentially provide us a lot of information for future missions. And I'm sorry, could you repeat the second question?
How did you feel when it surpassed your predictions about its flights?
Ingenuity, the personality of Ingenuity, I think, is made up of all of the personalities that have been on the team, as well as the personality that the public puts onto Ingenuity. So the personality gets bigger and bigger and bigger with every flight, and you get more and more attached. But at the same time, I feel like even with its final flight, it has still amazed us that we can still communicate with it, that we're still learning from it. It's sad to see Ginny not be with us anymore on a regular basis with Perseverance, but just such an amazing technology demonstration and machine, and it's a celebration of everything that the team and Ingenuity have accomplished.
If I could add on top of that, there was an acronym, a phrase that we used during development with Ingenuity. There were two, but the one I think is more appropriate here is Wendy, which stood for "We're not dead yet." And there were a lot of opportunities during development of Ingenuity before launch, engineering model down to flight model, delivery to the Kennedy Space Center. And there were always these curveballs that would get thrown to the team, and we'd say, Wendy, we're not dead yet, we're not dead yet. And it's funny now, Ingenuity is going to get the last laugh because she's still not dead yet, right? We've reached the end of our flight mission. She's not going to fly again. And we've within the team, this is not a scientific designation, but within the team, we've coined the area where her last airfield, Villanueva Hills, right? It's you can look it up, the etymology of the word, but the undying lands, in that she still refuses to quit. And we couldn't be more surprised, but B, more proud of what she's been able to accomplish.
The little helicopter that could. And thank you for teaching us about that acronym. Now we have that to use in our back pockets. We have Ronan Glover on LinkedIn who asks, what have been the most significant learnings in regards to the controllability of helicopter in Mars's atmosphere? That was a mouthful for me. Teddy, do you want to grab that one?
Yeah, there is a tome of information that we've collected here with every single flight. I've talked to it in the past as kind of this treasure trove is the other descriptor I use. Every flight that Ingenuity has flown, she's packaged a whole collection of data from our IMU, from our accelerometers, gyroscopes, our power system, and we send it back down to Earth. And our teams compare the prior estimate and the prior prediction of how Ingenuity would perform in a simulation. We have a 3D simulation environment here on Earth, versus how well she actually did on Mars. And we've learned an incredible amount. The first and the most exciting part is that all of the aerodynamic models that were developed at NASA Ames Research Center, Langley, and here at JPL, those were theories before launch. We now have ground truth, right? And we can hand this off to the next generation and say, this is actually how a helicopter performs at Mars, right? We thought the curve was going to look like this, and it actually looks like this, right? And the difference, that's the good stuff. That those are the lessons learned and the calibrations and the turning of the knobs that allows for your next aircraft, whether it be a helicopter or an aircraft, you name it, can now take advantage of that difference and that lesson learned. We don't have time here for during NASA Science Live, but there are interesting aerodynamics that are different between Earth and Mars. There's a lot of publications. I encourage you all to research the Ingenuity publications that delve into that if you're interested, of why the physics and the engineering of and the controllability specifically of flying in such a thin atmosphere is so much harder than Earth.
And a question for both of you coming up. Space Peacock on X wants to know, what is the Mars helicopter team's favorite memory from Ingenuity's journey? Teddy, I'll start with you.
I can't speak for the whole team because we haven't done a survey of the entire team's favorite, most democratic vote here. I will say I think it's safe to say that the most important one for everyone was Flight 1. And seeing the images from Ingenuity's perspective of Flight 1 happening, and you can see us in the video here celebrating, and what you see here is the altimeter plot. This was the helicopter's own telemetry confirming for us that, yes, the altimeter says that we raised up to a handful of meters and came back down. And then shortly thereafter, we got images from the helicopter itself and a video from Perseverance, really sealing the deal for us that, yes, everything worked perfectly. I think that was the most important part. If you ask every other team member, they'll all have their own favorite stories. But I think without hesitation, the most significant was flight number 1.
And
I think it's hard.
What would be your one? Oh, go ahead.
I think it's hard to top Flight 1. I can say another memorable moment, though, would be when we realized Ingenuity was contributing to the Perseverance mission. When it found a potential target or helped the scientists identify a potentially scientifically compelling target, I think that was pretty impressive. There was also when it imaged some of the entry, descent, landing gear was pretty exciting.
And Hitchhiker on Mars on X wants to know, can Perseverance survive without Ingenuity? Teddy, do you want to take that one?
Yeah. Absolutely. Ingenuity was a tech demo. Whether or not Ingenuity was on the rocket or not had no impact to Perseverance. Its core science objectives and its mission objectives have nothing to do with the Ingenuity project, and it has an important job to do, which is to collect samples so that we can bring them back to Earth and try and answer some pretty big questions about the uniqueness of life in the solar system. So absolutely, Perseverance is going to keep on doing its thing. With or without a helicopter has no impact.
And Chris on X wants to know, is it possible for Perseverance to reach Ingenuity to get more photos? And we have a similar question from Benjamin on YouTube, who asks, will the rover go over to Ingenuity and check the conditions? Teddy, both questions for you.
No, unfortunately, it's not in the plans. As you can imagine, there's a team of eager rover planners who jumped on that very quickly, that question, as soon as we realized we weren't going to fly again, of trying to understand, is it physically possible? Is it traversable? What are the risks? What are the hazards? One of the reasons we flew to this area is because there are large sand ripples, and in between the sand ripples, there's nice soft sand. It's good for landing, bad for feature tracking, as we've learned in the last 3 flights. That's not a good area for big, heavy rovers to be driving in. You can think of it as a sand trap, for example, right? So if you have a pickup truck, you don't want to be driving a pickup truck into a sand trap area and put the rover at risk for the sake of imaging the helicopter. The team will do their best along their strategic route here, to point their high-resolution camera at Ingenuity and get the best images possible, as close as they can, all schedule permitting, of course. But no, it is not possible for Perseverance to drive in without putting the rover at significant risk.
Thanks, Teddy. And we have lots of questions coming in, but just a reminder that if you have a question, use the hashtag AskNASA or leave them in the comment box. Tiffany, question for you. Ed Woody on LinkedIn asks, I know you must be overjoyed with the longevity of Ingenuity. What are some of the most important things you feel can be taken away from this and applied to future flights on another planet like Mars?
Well, some of the most important things, we talk a lot about system science on Mars, and to be able to potentially deploy sensors in the future, or to pick up samples, to carry cameras to areas that we can't, get to with a rover right now. So, novel mobility solutions. It'd be great to see inside of a volcano or Valles Marineris. And there's just some really exciting places that we would like to see on Mars that I could see us using future helicopters for. And they'll be more capable than Ingenuity, because Ingenuity has helped us learn so much about what can be accomplished. So I really look forward to the future and what we can do with the offspring of Ingenuity.
Thanks. And then Teddy, one for you. Someone on Twitter wants to know, could future missions include helicopters with spare parts so they could fix themselves?
Interesting question. So from physics first principles, yes. In fact, our partners who built a lot of the aircraft components that you can see when you look from the outside of Ingenuity, AeroVironment, that was an initial trade going back years of making the blades removable or not. And in future concept designs we have for next generation helicopters, that's also an option where you can remove a blade and swap a blade. So it is feasible to imagine a scenario in the future, right, where you could have a helicopter that could swap a leg, swap rotor blades. It's a fun robotics challenge to create an arm that can do that. Or, of course, you could also have human astronauts do it, right? Just like humans fly drones here on Earth, and you break a propeller and you swap the propeller out. I'm confident in the future we will have fleets of aircraft flying around at Mars, and human pilots either right in front or remotely operating them. But yes, in short, you can imagine a situation where you can make the parts interchangeable.
And then a follow-up question for Tiffany. The username, somebody that you used to know, maybe it's true for this one, on YouTube asks, Is there any way you could send helicopters like that to other planets?
Well, I don't want to say helicopters like that, but flying objects or aerial vehicles, controlled powered aerial vehicles. We do have the Dragonfly mission going to explore the Titan moon of Saturn. And it is not quite the same as Ingenuity. It is powered by a radioisotope thermal generator, and it's the size of a small car. It is also the primary mission, so this is not a technology demonstration. But Dragonfly is in development now, and really looking forward to seeing what it achieves in the future.
And Jim on Facebook wants to know what caused the damage to the blades, Teddy?
Sure. So our theory here is that it was ground contact, right? I say theory just to explain. We don't have video footage of what occurred, and we also don't know the exact chronology of how it unfolded because we lost that crucial bit of data right around the rough landing. I say rough landing because we're still on all 4 feet as opposed to a crash, right? But what we can say for certain is that at some point we had contact with our rotor blades with the surface. And another thing that we can say for certain is that we browned out around landing. What we don't know is did one cause the other or the other way around. We don't know if we had ground contact which caused the brownout or there was a brownout for another reason which then caused the helicopter to have contact with the ground. We will never know the answer to that question. Again, the team is going to try and collect as much data as we can, but we are certain that those last few seconds of landing, when we were about a meter off the ground from Flight 72, that data is unrecoverable because of the brownout and the power cycle. But we believe as a ground contact with the rotor system, we have photo evidence for 2 of the 4 blades that are damaged. And in the days ahead, we're going to try and collect additional photo evidence for the remaining 2 blades.
And Teddy, you actually have like a sample blade. Is there any way you can kind of show us where the damage occurred?
Right. So here is a prototype as a next generation blade, but it looks for the most part the same as Ingenuity's rotor blade. 2 things to keep in mind here. This is incredibly light. It's about 30 grams. Okay, almost nothing. The center of it, it's filled with foam. I don't know if it's easy to see there, and I'll show you just the cross section of incredibly how thin this rotor blade actually is, almost paper thin. Carbon fiber on the top, carbon fiber on the bottom, and then foam in the center. So if you can see the entire length of the blade here, this one's a little bit longer than Ingenuity's, but we believe right around here to the tip has been broken off. And I mentioned earlier, that's where most of the lift is kind of your last third, because that's the fastest moving part as it rotates in a circle.
Thank you, Teddy. And then we have a viewer on Facebook who wants to know, hello, is there water on Mars? Tiffany, want to take that one?
Absolutely. We've known for about 20 years, or we've suspected for about 20 years that there was water on Mars. Spirit and Opportunity helped prove that to us. Curiosity has been exploring Gale Crater, which used to be, a river. And then Jezero Crater, it was a delta. So absolutely, and we believe we know we have ice at the poles, and we believe we have ice closer to the equators underground. So absolutely, there used to be water on Mars, and 3.5-4 billion years ago, it had an atmosphere more similar to the way Earth is today.
Thank you. And Kieran on YouTube asks, was Ingenuity operated in real time, or were they programmed for autonomous operations? And how was that data relayed in that instant? Question for you, Teddy.
Not real time. We do what's called sequencing when we operate with Mars, and the main reason for that is the speed of light. So Mars and Earth are so far apart that to send a signal from one to the other, depending on where the 2 planets are in their orbit around the sun, can take about 15 minutes, right? That's okay for some applications. When you're trying to control one of the orbiters around Mars, for example, or trying to communicate with the rover, that's okay. But for a helicopter, your control loops are so blazingly fast. Your blades are spinning at 350 miles an hour, and you're only in the sky for about 90 seconds. So there's no time for you to joystick it. So instead, what the team does is we prepare a list of instructions, which we call a sequence. And our controllers here at JPL, we send that up through the Deep Space Network, collection of satellite dishes that send the information over to Mars. We have the Mars Relay Network, a collection of orbiters around Mars that get that data, send it to the Perseverance rover, and then finally over to the helicopter. We have a base station box on the rover that's our man in the middle, if you will. So once our script, our sequence, makes that long chain all the way to the helicopter, we're hands off. And then we trust the baby to do the right thing. And we go to sleep here on Earth, and we wake up and hope to hear good news. And it's worked miraculously well, that concept of operations, for the last 2.5 years.
And speaking of Ingenuity and Perseverance relaying with each other, Benjamin on YouTube wants to know, how many souls until Perseverance is out of range of Ingenuity for good?
We don't know the answer to that. It's strongly dependent on the answer to that is strongly dependent on the rover planners and the scientists' priorities in the weeks ahead. Their mission is to drive west and to go collect more of those precious samples we mentioned earlier. And if they find areas on the way that they want to sample on, or if they find difficult to traverse terrain, that may add a handful of days here or there in terms of communication. We believe that we have about 1 kilometer of telecom range, at least 1 kilometer if we have good line of sight with the rover. And our team has already done the analysis to understand where are the hills, where are the ridge lines, and kind of shading a map to really understand at what point do we think that'll be out of comms. I would say in the weeks ahead, a handful of weeks ahead here, we think we should still have good communications with Ingenuity, but we will know more as the days unfold here.
Thank you. And another question for you. A viewer on X wants to know, did Ingenuity possibly suffer some damage during Flight 71 when it made an emergency landing?
Great question. So theoretically, it's possible. Flight 71 had an emergency landing, and it was one of our rougher landings when you stack them up against all the other flights that we've had. Our horizontal velocity, when Ingenuity likes, I'll just use my hand here as an analogy. When we touch down with Ingenuity, we like to just touch down at about 1 meter per second. We also try testing slower, around 0.5 meter per second. It's very gentle. Vertical, almost no horizontal velocity, right? You don't want coming in on the side at an angle. With Flight 71, we had an emergency landing because of the blandness of the terrain underneath us. And there was a position and velocity tracking error as a result of that. So we actually did have some horizontal landing velocity coming down on the ground, on the order of a couple of meters per second. Now, the reason we thought we were still flight worthy, though, is after Flight 72, we did our typical baby stepping method to assess the health of the helicopter, where we did a 50 RPM spin, we did a high-speed spin, and we confirmed that our IMU didn't show any additional resonances, no aggressive shaking, and our imagery looked good. So everything on our nominal checklist was green across the board. So we think we just had a rough landing, and she handled it just fine, and we were ready to go for Flight 72. And I should also add, all of our flight telemetry through the majority of Flight 72 also looked nominal. It was a good takeoff. It was a good hold. It was a simple pop-up, right? It was really coming down on landing where the feature tracking really became a challenge for her. So it's not ruled out, but all evidence seems to suggest that she was still flight-worthy and healthy after the end of Flight 71.
All right, and Teddy, we're getting questions that are coming in real time. And I think this refers to one of your answers on how Ingenuity controlled things. Andreas on Facebook asks, when you mentioned the sequence, I'm thinking latitude and longitude like GPS data. How does that work on Mars?
Sure. So we don't have a global positioning system at Mars. And Ingenuity's navigation system is pretty simple. You got to remember, we designed Ingenuity to fly in the equivalent of a parking lot on Mars, right? Flat area with good feature terrains, but no big boulders or rocks to worry about. If you look at the map of Jezero Crater, okay, you can see really where the mission started was a very small area that Perseverance and the scientists and the Ingenuity team worked really, really carefully to try and pick out. It's kind of the little first yellow line segment on this animation here. It was a beautiful, perfect area for us. And then we really started spreading our wings and flying further and further and further to where we are now here in the Villanueva Hills area. That initial area, though, that first little yellow segment, was as close to a parking lot as you can get. Now, going back to the question, Raquel, the question specifically is, how did we design the feature tracking, or could you repeat it in terms of the question again?
Absolutely. When you mention the sequence, I'm thinking latitude and longitude, like GPS
yes.
data. How does that work on Mars?
Going back to that description of the parking lot, right? Ingenuity, when she first started the mission, assumed that she's at the center of your coordinate system. So you can think of it as north, east, and down. And there's just you have those three axes, and from there is your origin, and you're just navigating from your takeoff spot. So instead of GPS coordinates, it's just relative positions from takeoff. So we'll have waypoints that we code up in the sequence, and it says, okay, from 000, go to waypoint A, then waypoint B, then waypoint C, and then come down to land at waypoint D. And it's all referenced off of that original origin, which is your takeoff location.
Great. Ed, we have two more questions for you, Teddy, before we get back to Tiffany. The two questions go hand in hand. Janine on Facebook wants to know, how large is Ingenuity? And Andres wants to know, how heavy is Ingenuity on Mars?
Sure. So Ingenuity's rotor system, the biggest part of Ingenuity, it's 1.2 meters from tip to tip. So from the right tip to the left tip. And it, in terms of weight, I guess to convert to pounds, it's about 4 pounds, the total weight of Ingenuity, 1.8 kilos.
It's so wonderful to think about, like, how light it is, actually. So thank you for that,
Incredibly
Teddy.
light.
Now to get back to incredibly light. And Tiffany, a viewer on YouTube, wants to know, is there any common mission for Artemis and Mars?
Well, we have Moon to Mars. Common mission between Moon and I think that those are to be developed. Those are in the future. I don't think that we have, and we have the CLIPS mission right now, the Commercial Lunar Payload system or service contract that is allowing us to take payloads to the moon, that is part of the Artemis program, that crosses really between the Science Mission Directorate and then the Exploration Systems Mission Directorate. But in terms of a common Mars mission at this point, no, but we are planning for one in the future, most definitely.
Thanks, Tiffany. And Kate on YouTube wants to know, what are the challenges involved with accounting for blank surfaces for future helicopters? Teddy, I think this is a question for you.
Yeah, that's a wonderful question, and one that team's been buzzing with for the last couple of days since getting the news of Flight 72, right? A lot of what we do here at JPL is lessons learned, right? And how do we improve? How do we make things better? Going back to the idea of a parking lot in a feature-rich area, right? That's what we designed Ingenuity for, right? Was a very narrow use case, 30 sols, great. We found an area for it. We really pushed it to the limits, not only flying for the last 2.5 years and the physics of all that, but also in terms of the guidance, navigation, and control. We not only pushed the limits, and with Flight 72, we learned the limit, right? That's the limit for this set of hardware, and to your point, this camera, right? Our downward-looking navigation camera, the resolution of that camera defines the sort of terrain that we can fly over. So if you have a high-resolution camera, you can see the rocks. If you have a low-resolution camera, you can't see the rocks so well. So you can imagine a combination of how bland or featureless your terrain is and how good your camera is. That defines your capability. So for Ingenuity, right, for the beginning of the mission, we had oodles and oodles of margin. And then towards the end, we really pushed it, and she did a marvelous job at teaching us, right, exactly where that limit is. For next generations, there's some simple answers, which is you fly a better high-resolution camera, right? And this camera is now almost 10 years old, if not older than that. So there's easy, commercially available improvements that are also cheap. So the next generation of helicopters that go to Mars, and just in general using commercial off-the-shelf parts, will be better, higher resolution. And there are also other sensors you can add to the aircraft to help it observe the ground underneath it. But the easiest one is you fly a better camera for the next generation.
Thank you, Teddy. And Dan on YouTube wants to know, did Ingenuity ever fly during high winds or non-ideal weather?
Absolutely. We've been grounded actually because of storms and the weather forecast on Mars. It was a weird, interesting week for us, getting the weather report. I think we're all used to, having our flights be delayed on Earth because of weather. But as we approached fall in our first year of operation, we actually had a big dust storm arrive. And that grounded us, and it also it threw a lot of dust and sand into our mechanisms, and made it a little difficult for us to figure out how to fly again. We cleared ourselves off, created a sequence to wiggle the blades and push all the dust out of the actuators and fly again. We try to not fly if the winds that are predicted, are going to be, above 10 meters a second, significantly above that. Below that, we have a lot of experience with. But yes, it's happened now a couple times where we hear a weather report and we've stood down flight operations and just you wait for it to blow over and then try again next week.
Thank you, Teddy. And Bodie on X wants to know, has Ingenuity sent its last radio signal, or will we still be able to communicate with it?
Ingenuity does not have an off button. There's no way to stop her from waking up every single sol. The way she operates, though, is it's called listen before talk, which means that every single morning, Ingenuity wakes up at a predefined time and listens for a command from Perseverance within a 15-minute window. And if there's a command within the 15-minute window, she will reply. If there's not, she just goes back to bed and tries again next time. That's how we designed her for robustness, so that she could be fault tolerant in the event that Perseverance had something else to do during the tech demo. And that architecture means that moving forward, again, sol after sol, she'll keep going to sleep, waking up, listening for commands, and waking up on the following sol. If there's no hardware failures, right, then she'll just keep doing that. But in the years ahead, more thermal cycling, each one of those solder joints doing this. It's anyone's guess as to how long she could last trying to do that.
All right, and Teddy, a viewer on X wants to know, I'm curious to know how Ingenuity's flight will impact the future of Mars exploration. Teddy, I'm going to start with you on this one, but then Tiffany, if you could chime in as well, that'd be great.
Sure. I think Ingenuity already has, right? It already has answered the question for all of us here at JPL, within the larger NASA community, aerodynamicists around the planet, right? And that the box has been checked. It's not a fluke, right? Ingenuity did it 72 times. We know that it's possible, and we know that it's robust. And we know now that we're not limited to just rovers and landers and orbiters at Mars. This new aerial dimension has actually been unlocked, right? And now we're off to the races to figure out what do we all as humanity want to do with that, right? There's, the current generation of helicopters we're designing for next missions to Mars, and there's even more grandiose versions of aircraft that we're designing, Mars Science Helicopter, that are much bigger, the size of a pickup truck and a little bit bigger, 2 pickup trucks, right? And those platforms can bring scientists to the wall of a cliff, for example, or fly down a lava tube, or go to sensitive areas that we would never dare send a rover, either because of physical constraints or otherwise. So really, we've already unlocked it, and now it's for everyone to run with this capability.
And then I'd like to add something too. Actually, I think that the last few questions as well is Ingenuity survived the Martian winter. And again, there were questions about the storms, and there were some special conditions that the operations team had to contend with in terms of the battery power for the Martian winter. And maybe Teddy can talk a little bit more about that. But also during our solar conjunction for the couple of weeks every 2 years or so that we have the sun is between the Mars and Earth, that we can't enable communications quite so well. So we give a whole bunch of autonomous, or the team gives autonomous commands to Ingenuity, and that might be something for the future of Ingenuity. So over this last solar conjunction, it took a picture, I think, every day. I think Teddy could probably expand on a lot of that right there.
Yeah, so the team is busy right now thinking of interesting and useful and fun things to do with Ingenuity's wake-up sequence in the days ahead, right? Because eventually, we covered this already, Perseverance will leave out of comms range. So there's a lot of potential for us to take images, for example, and store them on board our flash file system. To the winter comments that Tiffany made, right? We designed Ingenuity just to survive in the spring. All right, so she has a solar panel on top and a battery system inside, and that's it in terms of generation and storage. And when your energy balance gets pushed to the limits, when you get to the winter, what happens is she will freeze. We saw that happen in the first winter. She made it out, right? And she was able to survive going down to negative 90 degrees Celsius every single night and back up to positive 20 degrees Celsius every single day. And the team expects that if we made it through one winter, there's a pretty good chance, hopefully, but we won't know. And we wish her the best of luck in terms of trying to do that. If the rover ever comes back into this area, right, we can try and see if she's responsive, but who knows, that's years down the road. And for the time being, all we're focused on is trying to make sure we get as much data off as we can in the time that we have allotted.
Tiffany, you brought up a great point about winter on Mars. For those who are watching, can you kind of describe what that's like?
I think probably somebody that interfaces with operations like Teddy might be able to share a little bit more about what that is actually like.
Sure. So just like here on Earth, right, there's seasons at Mars. And the time frames are different, right? But you still have evolving seasons. You have a summer, a spring, a winter, and a fall. And the big difference between what we're all used to here on Earth is winters on Mars. I mentioned earlier, negative 90 degrees Celsius, and that's just normal, right? The biggest change there, right, is going to be the temperatures. There's also more dust, right? It's not just your temperatures are changing, dust in the atmosphere. And for a solar-powered mission like Ingenuity, and we've seen this within their solar-powered missions that NASA has sent to Mars, as you move into winter, there are more storms, and those storms, and when I say storms, it's really like wind storms or dust storms. Those storms kick up more dust higher up into the atmosphere, and the more dust there is higher into the atmosphere, the less solar rays make it down to the surface. And that's why it gets really tricky for us operators to try and contend with that. And, can you shave off a little bit of usage here and try and, I think we're all used to trying to save battery on our cell phones, right? And you close as many apps as you can. Operators here at JPL try and do the same thing, right? And try and preserve as much of the energy that you can. But eventually you get to the point where you can't fight physics, right? And the energy needed to heat yourself overnight is this much, and the energy you generate every sol is right below it, right? And that's when the really tough freezing starts. And thankfully, as I said, we were very lucky that Ingenuity made it through the first winter. We're about to enter our second Mars winter for the Mars 2020 mission here. Perseverance is fine. It has the radioisotope thermoelectric generator on board, so they have plenty of heat energy and electric energy. But Ingenuity will be, every sol waking up and trying to heat herself. But we couldn't have asked for any more out of this little spacecraft, right? It's all sprinkles on top at this point.
Survived all that without a winter jacket, so
yes.
Impressive. We have just a couple more questions left. Jose on Facebook wants to know, which is the most important discovery of Ingenuity? I'll start with Tiffany on that one and then hand it over to Teddy.
The most important discovery of Ingenuity, gosh, there's so many things that are important in terms of technology and how it will feed forward. But I know I'm not going to get the numbers right here, but I think the Ingenuity flying on Mars is the equivalent to flying at 90,000 feet on Earth. Teddy, did I get that right? Close?
Yep.
I mean, Yeah, and that's, from my understanding, that's impossible here, right? So that they've made it possible on Mars, I think that alone is pretty astounding. But they've been, over time throughout those 72 flights, they increased the speed, they increased the altitude, they did left to right and a whole bunch of technology things, and then helped the scientists as well. All of it was really amazing, and then I think also imaging the entry, descent, landing gear. I think a lot of folks were really happy that they were able to get the detail that they could with those photos. Teddy, do you have more to add on that?
Yeah, I couldn't agree on the aerodynamic front. One thing that is close to my heart, right, is really the paradigm shift in how we think about building things for space, right? I've said it now 5 times during the NASA Science Live. We used cell phone parts, right? Low cost, high availability, and no flight heritage, right? But we signed up for that challenge, and what I would, think of this as a call to action for future generations is the benefit is to try and see the benefit of taking those risks on, right? Because now you have you can think of them as supercomputers on Mars, right? Ingenuity's chip is, if you take everything we sent to Mars and deep space, the Voyager probes, add it all up together, Ingenuity's processor alone is more than 100 times more powerful than all of that combined, right? And I really think that should unlock a lot of capability for the next mission planners, the next mission designers to try and harness that, right? That's a huge leap forward, and I'm excited to see, what the next robots on Mars and other planets are going to be able to do because of that new capability.
Great. And that is all the time we have today. So thank you both for joining us and providing some great answers.
Thank you so much for having me. I really enjoyed it.
Thank you very much, Raquel. Really appreciate it.
Yeah, and to learn more about the legacy of the Mars helicopter, visit go.nasa.gov/Ingenuity. You're also invited to join us in celebrating Ingenuity's legacy by sharing your favorite moments or farewell messages on social media with the hashtag #ThanksIngenuity. You can also keep up with the Perseverance rover, which is still exploring Jezero Crater, on Facebook and X. Congratulations to the team on this historic mission. Now let's hear some parting thoughts from those who knew Ingenuity best.
We have opened the skies of another planet.
Ingenuity really opened the door for aerial exploration on Mars.
It's just been this plucky little helicopter that just defied everybody's expectations.
I'm incredibly proud and grateful for all that Ingenuity has been able to give us.
What would you say to Ingenuity directly one last time?
You're gonna make me cry,
What would I say to Ingenuity?
It's really hard to say goodbye to you.
I would say thank you.
Ingenuity, thank you for bringing us all together.
Thank you for leading the charge in our adventure on Mars, and we will never forget you.
Rest well.
Thank you, Ingenuity.
Thank you, Ingenuity.
Thanks, Ingenuity.
Thanks, Ingenuity.